Hart of Hart & Son, the outfit that's putting up this building. But this time I'm playing hooky. You see, this is the first time I've ever seen this building. David's solo job. First one he's handled by himself. David's the son of Hart & Son. That's Dave. It's a pretty nice feeling for a man to have his son following right along in the same business. But it wasn't always that way. The year before he finished school, he wasn't sure where his steps would take him. Naturally, I wanted to see him in the building business. I had to do a little campaigning. It wasn't too hard. That year, Dave was doing nothing but finding out. Wanted to know everything he could about my business before he decided on anything. Steel frame construction is what I know most about, and I figured showing him was better than telling him. And since the work of building really starts in the fabricating shop, that's where we went first. We started right with the shop drawing in the fabricator's drafting room. After the architect figures out what he wants the building to look like, and decides he wants to use steel to build it, he has the structural engineer figure out what steel, what the stresses are, what size and what shape steel will be needed to stand those stresses. He can do this because we can predict steel's reaction to any given condition without guesswork. When he calls for an 18-inch, 50-pound wide flange beam, he knows it'll do the job. No danger of it being too small. No waste involved in making it any bigger. In a way, the building is really built right here on the drawing board before a piece of steel is touched. Because next, the fabricator's engineer steps in. He figures out just what every connection will be, how big, how many rivets or bolts, or how much welding each needs. Every last detail, and incorporates it all in the shop drawing. And every move he makes is checked by someone else before it's ready to be blueprinted for use. Prints of the smaller details, like connections, that will be used in large numbers, go to the template shop. Templates are actual, full-size models of the detail to be fabricated. Except for the fact that it's made of cardboard, this is the detail that will go into the building. Same size, same number of holes, same everything. And this template guarantees that every single detail of this particular shape, demanded by the shop drawing, will be identical. To make doubly sure that the finished template agrees with the shop drawing, it is rechecked. Actually, a big start on construction has been made before anyone even begins to handle steel. Before, in fact, the building site itself is ready. That's a big advantage for everyone concerned. Even the plain material we start with is a lot more than raw material. It's a manufactured article with rigorous tests and a guarantee behind it, starting right back at the mill where the steel was rolled. This mill test report is that guarantee. The steel we use has to conform to strict standards in its yield point, its tensile strength, its size, and its chemical analysis. Tests begin with samples of the heat taken from the open hearth. In the laboratory, chemical analyses are continually made until the pour, and this is followed with a detailed study of the physical properties of each heat. Deviations due to human error won't get by these tests. After the mill, human error can't get in. The qualities of steel are uniform and frozen into the steel itself. That's why now, even before the steel is cut into the shapes we need, we know its strength, durability, and we know these will not change. Now the actual fabrication of our frame starts. The first step is cutting the pieces to exact size, according to the shop drawing. Columns and beams, cut to exact size, are then sent to the layout skids. Here, the layout man, working from the shop drawing, marks each piece for prick punching. Of holes to be repeated many times, a wooden template made from the shop drawing is used. This template guarantees the consistent pattern will be punched in every piece. In preparing details, smaller connecting pieces, cardboard templates are used as guides for the actual punching. The details held temporarily in place are tack welded to the column to hold them in their exact position until they can be riveted. Even though everything so far has been done according to the carefully worked out shop drawings, once more, every piece is checked against the drawing. And each piece is marked to show its job number, its position in the job, the derrick which will handle it at the site, and with columns, even the direction it will face is shown. When all this is done, the checked and marked piece is painted. Then it goes to the yard to wait until the day it is needed for shipment to the site. Work that with other building materials wouldn't be underway until the building started going up is started and finished in these pieces haven't even left the plant. This is one of steel's big savings. Saving in time, saving of money. David was good and interested now, so the next move was to look over some buildings actually going up. Funny, for all the jobs I'd handled since he was born, Dave had never yet been on the inside of any of them. We looked over a lot of jobs going up, and right off, Dave spotted another advantage. Construction at the site is quicker with steel, too. As fast as the material is delivered, it goes into place. temporary construction necessary to hold the frame together. It holds itself. Accuracy makes for speed, too. Back at the drawing board stage, the draftsman knew these pieces would line up exactly. Nothing has to be made to fit on the site. Steel is a compact material. The members are smaller for the loads they have to bear than any other commonly used building material. And the less space taken up by the frame of the building means, naturally, more floor space for the owner. That's money in his pocket. Here's another thing. There's no waiting to work on any level once the frame is in on that level. The frame is just as strong now as it will be for the life of the building. And once it's in place, the workman can move in to lay the floors and fireproof the frame. Some people call all the work on a steel frame building at this stage fireproofing. That's a mistake. What is commonly referred to as fireproofing is, for the greatest part, simply final finish, such as the floor slab and outside masonry, which you can find in any type of building. Here is a model of a typical light occupancy column, girder, I-beam. The actual fireproofing in the steel frame is simply encasing with one material or another whatever parts of these members are not already fireproofed by finishing material. The beams with poured concrete floor slabs are fairly heavy members spaced widely. For this method, forms must be erected around column, girder, and beams. Next, the reinforcing rods. Then the concrete is poured so that the members are completely covered. Then the forms are removed. If the design calls for a flush ceiling, metal lath must be attached to the beams. And there is still the finishing job, plaster for a smooth appearance. There are many combinations of covering materials. Sometimes the column and girder will be covered with clay tile, and the other members with poured concrete. And there is still, of course, the operation of the finished plastering. A more recent technique, and one which David is using on part of his first job, is vermiculite gypsum plaster. This calls for a much lighter floor construction, light joists, spaced closer together. This in turn means that the concrete floor slab can be lighter. And since the building is to be plaster finished, that's the next step, only using vermiculite gypsum plaster. No building of forms, no extra work taking them off. There's a big saving in weight, too, which means that the original design can call for lighter steel throughout. David and I had looked over a fabrication shop pretty carefully and seen the materials go up on the site. And I think he was beginning to see why I was so sold on steel. Not just for the big job, the job where steel's the only thing you can use. No, the smaller jobs as well. Any job where you want a dependable material, speed and accuracy, as well as overall economy. Like this factory, one of our first jobs. Hospitals are naturals, too. Same goes for a rigid frame structure like this auditorium, where there can't be any structural members below the high ceiling. Garages like this, and movie theaters. In these long span jobs, steel is the only material I know of that can do the job at all. Highway crossovers, commercial buildings, both of these are naturals for steel. This is one we went to Canada on. Cold weather or hot, it doesn't matter. We worked through a lot of pretty bad weather, but we've never had to wait on the weather. Alterations are easier with steel. Just as with the original construction, a lot of work is done without coming near the building. With alterations, this can be pretty important. Here's a telephone exchange we worked on. We added 6 stories to this building without interrupting the work going on inside for a single hour. The salvage value of a building is no mean consideration. While this is not part of our job, it's important to the owner to know that steel doesn't lose any of the permanence it has by being second-hand. The strength, remember, is frozen into it at the mill and is in to stay. Steel's value as scrap is something most other materials don't have. What it all adds up to is that when you take down a steel frame building, you have something you can sell. That's better than a mountain of rubble you have to pay someone to cart away. There's another feature of structural steel you don't hear much about, but it's fairly common and important. A new dam made this bridge useless in its original location. But because it was made of steel, they were able to move the span 78 miles upstream. The bridge was back in service. After Dave had looked it all over, he got the general idea. If steel is what the men wanted and had to have to build the Golden Gate Bridge and the Empire State Building, the world's tallest structure, and the Merchandise Mart in Chicago, the world's largest building, then steel is what we wanted for lighter construction, too. That made sense to both of us. David is an important part of Hart & Son now. We've handled a lot of jobs together, and we'll handle a lot more. And we like steel because it's a material we can know it ahead of time, count on its performance forever. Not just Hart & Son either. There are more than 5,000 builders like us across the country, with construction going on every day. And we're building with steel.